Welcome back to Mentivia. In this video, we're going to explore the essential rules that determine how electrons arrange themselves inside atoms, key to understanding chemical behavior and atomic stability. Hi, I'm Marc from Mentivia. Today, we're diving into three foundational principles that shape electron configuration: the Aufbau Principle, the Pauli Exclusion Principle, and Hund's rule. These rules explain how electrons fill atomic orbitals, why no two electrons in an atom can share the same set of quantum numbers, and how electrons prefer to occupy orbitals singly before pairing up. Understanding these concepts gives us insight into how atoms form bonds, react with other elements, and maintain their structure. Let's break them down and see how they guide the architecture of matter. Let's start with the Aufbau Principle, a German term meaning building up. This rule states that electrons will always occupy the lowest energy orbitals available first before moving to higher energy ones. Think of it like filling seats on a bus. You fill the front seats first before moving to the back. For instance, the 1s orbital, being the closest to the nucleus, has the lowest energy and is filled first. After 1s is full, electrons then proceed to fill the 2s orbital, which is next in energy. Only once 2s is completely filled do electrons then start to occupy the 2p orbitals. This systematic filling ensures the most stable electron configuration. Next, we have the Pauli Exclusion Principle. This principle is fundamental to understanding how many electrons can occupy a single orbital. It states that an atomic orbital can hold a maximum of 2 electrons, and these 2 electrons must always have opposite spins. Imagine an orbital as a small room. Only 2 occupants are allowed, and they must be distinct. The opposite spins, often represented as an up arrow and a down arrow, ensure that each electron has a unique set of quantum numbers, which is a core tenet of quantum mechanics. Without this, all electrons would try to occupy the exact same state, which is physically impossible. This requirement for opposite spins is crucial for minimizing electron-electron repulsion within the confined space of an orbital. By having opposite spins, the electrons create opposing magnetic fields that partially cancel each other out, leading to a more stable arrangement than if their spins were parallel. Finally, let's discuss Hund's rule of maximum multiplicity. This rule applies when you have multiple orbitals of the same energy, known as degenerate orbitals, such as the 3p orbitals or the 5d orbitals within a sublevel. Hund's rule states that electrons will occupy these degenerate orbitals singly with parallel spins before any orbital is occupied by a second electron. Imagine 3 empty seats in a row on our bus. Rather than 2 people sitting together when other seats are empty, each person will take their own seat first. Only when all seats have one person will a second person sit next to someone. This minimizes electron-electron repulsion, making the atom more stable. The reason for this behavior is to minimize the electrostatic repulsion between electrons. Electrons are negatively charged, so they naturally repel each other. By spreading out into separate orbitals within the same sublevel and maintaining parallel spins, they achieve a lower energy, more stable configuration. Pairing up only occurs when there are no other empty degenerate orbitals available. So, to recap, the Aufbau Principle tells us to fill from the lowest energy up. The Pauli Exclusion Principle limits each orbital to 2 electrons with opposite spins, and Hund's rule guides us to fill degenerate orbitals singly before pairing. Mastering these 3 rules is essential for accurately predicting and understanding electron configurations, which in turn explains much of an element's chemical behavior. Thanks for watching. If you found this video helpful, be sure to check out mentivia.com for more educational content. There you'll find completely free e-learnings, videos, and articles designed to deepen your understanding across a wide range of topics. And if you'd like to keep learning with us, don't forget to subscribe to the channel. We've got plenty more coming your way.